morning. Welcome to WPHY News 25. My name is Amanda Rodriguez.
And I'm Lane Underhill. Today, we have some very exciting guests who will be discussing a new development in the mapping of Earth's ocean tides.
Let us welcome Dr. Casey and Dr. Girding.
Good morning, and thank you for having us.
Thank you for joining us. Would you like to explain what exactly this new development is?
Yes, absolutely. Previously, satellites have been used to see the movement of the Earth's surface. However, this is limited to only certain depths. With SWARM, we have been able to focus on the magnetism created by electric currents that are produced at all ocean depths.
And for the people who may not know, what exactly is SWARM?
SWARM is a trio of satellites put into space by the European Space Agency in an attempt to study the Earth's magnetic field. The primary objectives of SWARM were to study the Earth's core dynamics, lithosphere magnetization, and the 3D electrical conductivity of the mantle.
Okay, great. So what exactly produces the electric current in the ocean?
Electric currents are able to produce in the ocean due to presence of salts, an electric conductor. When this electrical conducting material moves through the field lines of Earth's magnetic field, it creates electric currents within the ocean. Since every electric current contains a magnetic field, the SWARM satellites are able to pick up on these magnetic fields. This is what we use to chart movement of ocean tides.
These tides create a much smaller magnetic field than the Earth's. The Earth's magnetic field ranges from 30,000 nanoteslas at the equator to 60,000 nanoteslas at the poles. Comparatively, the tide's magnetic field is 2.5 nanoteslas. This is 20,000 times smaller than the Earth's.
Wow, that is extremely small. How were you able to create such a detailed picture of the tidal movements?
A huge difference has been made in using 3 satellites instead of 1. We've been able to see the same phenomena from many different perspectives. Therefore, we've been able to see a smaller scale structures involved and extract very small magnetic fields.
And what were you able to learn about the Earth with this new visualization created?
This newfound understanding of the ocean and tides with the magnetic field of the Earth, we are able to analyze the ocean floor movement and movement patterns beneath the crust and in the mantle.
Now, you'll have to excuse me, but I've only taken some basic physics courses in my life. So could you provide a little background on electric currents and magnetic fields?
Yeah, so the concept that an electric current produces a magnetic field was brought about by Ørsted when he discovered that a compass needle moves when it is brought near a wire carrying an electric current. A right-hand rule can be used when determining the direction of the magnetic field lines.
And what is a right-hand rule?
The right-hand rule involves pointing one's right thumb in the direction that the electrical current is moving and then curling the other 4 fingers in the direction of the magnetic field. For a magnetic field creating an electric current, it is called an induced current. Faraday found that this electric current can only be created if there is a changing magnetic field.
Wow, thank you so much. What does this mean for the future? Is the SWARM project now done, over, and worthless after the discovery?
Well, SWARM was launched in November of 2013, but finished in its orbit commissioning in May of 2014. We've discovered so much since then, and we've uncovered a direct link between GPS blackouts of low Earth orbiting satellites and thunderstorms in the ionosphere. We've revealed information about the foundation of the Earth's core, and even discovered some atmospheric phenomena.
Yeah, as long as satellites keep orbiting the Earth as they are and collecting data, we will continue to analyze what they pick up in hopes of discovering something we have yet to see or understand.
Well, great. Thank you so much for coming today and telling us all about SWARM.
Thank you for having us.